Welcome back to class. Welcome to Chapter 6, the labor market. In the last part of this chapter, we would like to derive one model and display this model in a diagram where we have the real wage on the vertical axis and the unemployment rate on the horizontal axis. You can see here that the wage setting relationship plays a role and the price setting relationship also plays a role. So WS, that's the wage setting relationship, PS is a price setting relation. In the intersection of these two curves, we can determine two endogenous variables. So the real wage is endogenous and also the unemployment rate is an endogenous variable. Let's have a look how we can derive these two curves. We start on slide number 19 with equation 1. We assume that the nominal wage depends on the expected price level and then also a function. This function depends in a negative way on the unemployment rate and in a positive way on this fundamental variable Z. The nominal wage is the larger the expected price level PE. The nominal wage is the lower, the higher the unemployment rate, and the nominal wage is the higher the value of this fundamental variable Z. In case that you are interested in one specific function which fulfills these characteristics here, depending in a positive way on Z, depending in a negative way on U, here comes the example. In case that the nominal wage depends on the expected price level times Z minus U in brackets, then this function here fulfills the criteria mentioned above. In case that Z increases, the nominal wage increases, and in case that U increases, the nominal wage decreases. So the expected price level seems to be important. Why is that? It's due to the fact that the nominal wages are fixed for some time period in the future. Nominal wages, like the wages we always talk about, let's say 2,000 euros, these nominal wages are fixed by the labor unions and the employer associations for some time period in the future. The nominal wages are not so important, but the expected real wage is. The expected real wage is given by nominal wage over the expected price level. What does real wage imply? Let's assume we have a nominal wage of 2,000 euros and the price of 1 bar of chocolate is expected to be 1 euro. Then our expected real wage is equal to 2,000 bars of chocolate. However, when the expected price level for a bar of chocolate is 2 euros, then it is the case with 2,000 euros nominal income, you can only afford 1,000 bars of chocolate. So the real wage is the lower, the higher the expected or realized price level. Of course, it's important what you can buy for your wage and not the nominal value. When the wage contracts are settled, the relevant price has not materialized, so we don't know the chocolate price in the future, and therefore the actors like the labor unions and employer associations, they have to build expectations about the price level in the future, which is the expected price level. Other factors is that there we have to mention the level of unemployment benefits and also the duration for which unemployment benefits are granted. The wage setting equation. Let's come up with some assumptions. In chapter 6, we are assuming that the realized price level P is equal to the expected price level PE. So the agents do not make a forecast error. This is important in chapter 6. We will depart from this assumption in chapter 7, where we assume that P is not always equal to PE. So this is one special assumption we make in Chapter 6. When we take into account that the realized price level P is equal to the expected one, then we can substitute P into this equation instead of PE. This is what we have done here, and now we would like to compute the real wage. So we have to divide this relationship by P to put P on the other hand side of the equation, and we get to equation 4. The real wage is equal to this function which depends on U and Z. We have a negative relationship between the real wage and the unemployment rate, and the intuition is the larger the unemployment rate, the lower the bargaining power of the workers or the labor unions, and hence the lower the real wage. Due to the fact that there is a negative relationship between the real wage and the unemployment rate, it is the case that the wage setting relationship is downward sloping in this diagram. There is a negative relationship between the real wage and the unemployment rate. In case that the unemployment rate is high, the real wage is low. And in case that the unemployment rate is low, the real wage will be high. Let's have a look at the second curve, the price setting relationship. Let's derive also this relationship. Let's talk about the price determination. The assumptions are as follows, that price is a function of the cost structure of the company, and the cost structure will depend on the production function. Here in equation 5, we have one very simple production function. GDP, the output, depends on the number of labor units employed by the company and also on this variable A. Variable A is called labor productivity. Our assumption will be that A is a constant and A will be equal to 1. Therefore, our production function is even more simple. It's equal to the following expression, Y equal to N. One worker can produce 1 unit of output. One example of the real world which comes close to this relationship is university. When you have one professor, you can give 1 lecture. When you want to have 5 lectures, you need 5 professors. So, of course, this seems to be the case that Y is equal to 1. This is a production function in the university sector. A represents labor productivity, and an innovation could lead to a situation where A increases. Let's assume here that A increases from 1 to 2. Like due to some innovations, professors are becoming more productive, so that one professor can give 2 lectures simultaneously. For example, when we use video lectures, it's possible that one professor is able to give like 2 lectures simultaneously. Therefore, we can model an innovation by increasing the labor productivity A. We assume, furthermore, that the cost of 1 unit of additional output is equal to the cost of 1 additional unit of labor. And the cost of 1 additional unit of labor is equal to the wage rate W. So the marginal cost of 1 additional unit of output is equal to the wage rate. Price setting, of course, also depends on the market structure. And in the market structure of perfect competition, we have the profit maximization condition that price has to be equal to marginal cost, so P has to be equal to W. But here in Chapter 6, we are assuming that we are not in the market structure of perfect competition. We assume that the price is larger than marginal cost due to the fact that the companies are able to charge a markup. So the companies have some pricing power they are able to charge a markup so that the price level is higher than the marginal cost. The higher the market power of the companies, the higher the markup, and hence the higher the price level. In case that we are in the market structure of perfect competition, the companies have no pricing power at all, so mu will be equal to 0, and then we are once more in the situation where price is equal to marginal cost. Let's also give one example here. Let's first assume that universities are operating in the market structure of perfect competition. The salary of one professor is 5,000 euros, and hence the output is sold for 5,000 euros. So the wage rate is equal to the price of the lecture. In case that the university has some market power, in case that the universities have pricing power, they maybe charge a markup. Let's assume that the markup is equal to 0.5. What does that imply? In case that the markup is equal to 0.5, then the price will be not equal to 5,000, but to 7,500. The wage rate is still 5,000. The price will be raised to the level of 7,500, and hence the universities are able to generate a profit of 2,500 euros. We can either interpret this markup mu as a kind of profit margin. So we can regard mu as a kind of profit margin. Another interpretation could be that the university is not only using labor, but for example, the university also has to provide a heating system to heat the lecture halls in the winter times, and hence the university in the end has to pay the oil bill. The oil price will be important. And hence we can also regard the markup, the 2,500 euros, as a kind of contribution to pay for all the other factors of production. And hence when the oil price increase, then the universities have to increase mu, the markup, in order to pay the oil price bill. So we can also regard mu as a kind of markup in order to pay the other factors, and in case that the oil price increases, we can increase this mu factor in equation number 9. So let's derive this price setting relationship like this horizontal line in this diagram. We start with this relationship. Afterwards, we put P on the other hand side of the equation. We want to isolate the real wage, W over P, on one hand side of the equation. So we have to put this 1 plus mu in the denominator on the left hand side. So we get to this relationship here. The real wage is equal to 1 over 1 plus mu. So it is the case that the price setting behavior also influences the real wage. The larger the markup, the larger the price level, and hence the lower the real wage. So price setting does not depend on the unemployment rate. We don't have an unemployment rate on the right hand side, and therefore the price setting curve is a horizontal line in our real wage unemployment diagram. So this is the relationship. Wage setting curve is downward sloping. The price setting relationship is a horizontal line. At this point here, 1 over 1 plus mu is defining how far the price setting relationship is away from the origin. With two equations, we can solve for two unknown variables. We can solve for the real wage and for the unemployment rate. These are the endogenous variables. This unemployment rate in equilibrium has a special name. It's called, or abbreviated by UN, and it's called the natural rate of unemployment. So the equilibrium rate of unemployment is labeled the natural rate of unemployment. But the natural rate of unemployment is not an exogenous variable. It is an endogenous one. It can be influenced by economic policy. So the policymaker has an influence on the natural rate of unemployment. In case that the policymaker change the structure of the labor market, the policymaker can influence the equilibrium level of unemployment. Therefore, some economists argue that it's better to talk about the structural rate of unemployment, because the structure of the labor market determines the equilibrium level of unemployment. Let's directly give one example. So first, we are assuming that the economy is in an equilibrium in point A, and then the government increases the unemployment benefits. This, of course, affects the wage-setting relationship via this variable Z. The variable Z increases, and therefore the wage-setting curve shifts upwards or to the right. We can look for the new equilibrium. It is the intersection of the new wage-setting curve and the price-setting relationship. So A prime is a new equilibrium. So the increase of the unemployment benefits has no impact on the real wage. The real wage stays constant, but it increases the natural level of unemployment. Why is that? Let's try to get the intuition. An increase of the unemployment benefit Z leads at a given level of natural rate of unemployment to a higher reservation wage, and therefore the workers demand a higher real wage. So the wage setting curve shifts upwards. But the companies are not willing to increase the real wage because of the fact that nothing has changed on the side of the companies. Like the production function is the same. This stand of technological knowledge, A, is the same as before. The pricing power and the markup is the same as before. So nothing has changed on the sides of the companies. And therefore, the companies are not willing to increase the real wage, and they will start to lay off workers. The unemployment rate increases in the adjustment process. And therefore, the bargaining power of the workers and the labor unions is reduced. The workers are afraid of becoming unemployed, and this reduces the bargaining power of the workers and the labor unions, so the real wage is reduced again. So the real wage is on the same level in A and A prime, but the level of unemployment has increased. When we look at this example, it is indeed the case that the policymaker changes the structure of the labor market and the equilibrium level of unemployment increases, and hence it might be a good idea to talk about the structural level of unemployment. Nevertheless, natural rate of unemployment is also a very common label for the equilibrium level of unemployment. In the last part of chapter 6, we provide an outlook with respect to what's going on in chapter 7. We want to highlight the relationship between unemployment and employment and the output level. So let's once more stress that the number of unemployed is the large U variable. The number of the employed is this N, and the labor force is abbreviated with L. The unemployment rate, small u, is equal to the number of people which are unemployed divided by the labor force. The number of people which are unemployed is also equal to the labor force minus the people which are employed, so L minus N. We have 2 times this L here in case that we write this expression on 2 fractions. Then this L will cancel out against that L. We get a 1 here. So U is equal to 1 minus N over L. In the next step, we are solving this relationship for n because we want to have a relationship between employment and the rate of unemployment. So let's solve it for n. In the first step, we put this u on the other hand side of the equation, pops up with a negative sign. And also we put this minus n over L on the other hand side of the equation, pops up with a positive sign. Now we can multiply through by L and we have isolated n on one hand side of the equation. Multiply through, we get n is equal to L times 1 minus u. In the equilibrium, it is the case that the economy realizes the natural level of unemployment. When we insert the natural level of unemployment in this equation, then we get on the left-hand side the number of employed people in equilibrium, the natural level of employment. Let's come up with one numerical example. Let's assume that the equilibrium level of unemployment is equal to 5%, and the labor force should be equal to 100 people. 1 minus the unemployment rate is equal to the employment rate, and the employment rate is 95% or 0.95. When we multiply through 0.95 times the number of people in the labor force times 100, we get the information here that the natural level of employment is equal to 95 people. 95 people are working in the companies, and when we insert 95 people in the production function, then it's a case that the number of output will be equal to 95. So 95 professors are have a job at the universities, so the number of lectures produced is equal to 95. When we on top take into consideration the main result of the previous lecture and we insert the right-hand side of this equation in equation 17, then we get the following relationship. With an unemployment rate of 5%, the employment rate is 95%. In the labor force, there are 100 people. And hence, when we are putting like 95 people into this production function, then the level of output will be equal to 95. The natural level of output is equal to 95 lectures. Here you can clearly see that there is a relationship between the labor market equilibrium and the supply side in our economy. This will be the main theme of chapter 7, that we also have a close look at the supply side of the economy. This is the end of this lecture. Have a nice day. Bye-bye.